Okay, we're going to look at the circular motion assignment. This one was done generally okay, but I think there's some presentation issues that you have to be careful of, and of course some other theory stuff lah. All right. Okay, so you have first question. A plane traveling at 170 meters per second, making horizontal circular turn of the radius 15 km by banking. Assuming the lift force generated by the wings is perpendicular to its wings, calculate the banking angle theta. Okay, so for this one here, right, it's important to extend this diagram a little bit by drawing the circle towards the center here. So this circle is this way, right? So this center is here, and this distance is 15 km, alright? So you need some kind of centripetal force that's acting in this direction, alright? Fc. Okay, so if we redraw this setup, okay, so if you just draw the plane over here, okay, at this angle, oops, right, draw it this way, like that, and then you have this is your theta, your L is this way, this L, this is theta, right? Then you have your weight here. Okay, this is what you have. Okay, then you need to break it down, break your L into X and Y components. So I'm going to draw this in red color here. So you're going to have your Lx, and then you're going to have your Ly, right? So these are two forces over here. Okay, so your net horizontal force is the one that provides your centripetal force. So in this case, your only horizontal force is Lx. Okay, so Lx is equal to L sine theta. All right, because you can see from the trigo relationship, this is because you're using this angle here, right? So this one will give you this will be given by sine theta. Okay, make sure you convert this the 15 km to meters. All right. Okay, so that's your net horizontal force. That's your equation 1. Okay, second equation to form is your net vertical force. Okay, so for most of you here, right, you did not write in these two expressions. You don't say this is net horizontal and net vertical. Even you're lazy, right, just put summation of fx and summation of fy. That's okay as well. Okay, just make it clear lah. Okay, so this one will be L cosine theta equals to mg. So this is just your weight, and then this is Ly. Alright, so because the only two vertical forces you have is Ly and your weight over here. So you can form the second equation. Okay, then after you realize, oh, this is sine theta and this is cosine theta, right? You can combine them to give you your tangent theta. Okay, you should get 11.1 degrees. No issue about this. Alright, so there were a few of you who just skip steps straight away to this portion here. This is not correct. You need to show the working above. You need to show the pre-working here first. Alright, this is important. Okay, so this is question 1. Okay, next you have the plane leveling out such that the wings are horizontal while still flying the same speed. So the magnitude of the lift remains the same. So lift force remains the same. Explain whether the plane will ascend, descend, or continue to fly at the same height. Alright, so since the plane force remains the same, exceeds the upward force, downward weight, right? The plane experiences net upward force. Okay, so I change the marking scheme a little bit to make you show that you need to express you need to show how your weight is smaller than your smaller than your lift force, right? So you can go back to your first equation. You can say because your Ly is equals to W, that means your L cosine theta is equals to W. That means your L is equals to W over cosine theta, which is more than your weight. Okay, so therefore your plane will ascend. Okay, so you need to show some idea that you understand that your lift force, the y component of lift force is larger than weight just now, is equals to your weight just now. So when you put in, you now is vertical, right? So your L is larger than your weight. All right. Okay, so this is the question 1. Okay, next you have this one over here. Okay, small ball of mass C fixed to an end of a light rigid rod. Okay, the ball is made to move at constant speed. So here there's a leap of faith that you have to do. Okay, you need to understand that when the ball is going round, right, there's no change in your velocity. Okay, no change in the speed of the ball, which is not usual because by right, remember when we talk about circular motion, right, when we say that, oh, the ball at first is at this point here, this is the ball here moving down to here, right? Here, right? Okay, there is a change in GPE because there's a change in your height. Okay, there's delta H. Okay, so there's a loss in your GPE and therefore gain in KE. And then if you go back up here, right, there's also a gain in the height. So gain height by right, you should gain GPE. Okay, but here, right, we are just assuming that there is a motor in the center here. The motor is keeping the speed constant. Okay, then yeah. So basically the motor is providing energy for your object to come to the top here at the same speed. And then if you think about it, now when it's going down, right, your motor has to take away energy because now when it's going down, it's using GPE, so by right is converted to KE, right? So this energy is taken away by the motor as well. Okay, so you can see that the motor is kind of accelerating upwards and then decelerating downwards as well. All right. So we for the sake of this question, we just gonna assume it as an ideal situation like this. Right. So then you have the length of the rod 0.72 meters. The rod is light, so there's no mass. Okay. Then you are told that when the rod is vertical with the ball above C, the tension T is given by T equals to 2 mg. So it means you have a tension force here. This tension here. Let me just draw at the side slightly. So this is T, and this is equals to 2 mg. Okay, for the position shown in figure 2.1, explain why centripetal force is larger than 2 mg. Okay, because you don't forget you also have your weight component acting here. You're gonna have a weight acting downwards here as well. And this is weight, this is equal to mg. Okay, the problem with this one is that I went back to look at the answer key when I was marking, right? I realized a lot of you, okay, most of you could say that is equals to the vector sum of the weight and tension, but you did not say that both are acting downwards. Okay, so it can be seen as a simple assumption, but I think it's good to just say it out clearly so that there's no ambiguity in answer. All right. Next, you have to work out your centripetal force. Okay, so this is weight plus tension simply. So you have your mg plus 2 mg. So mg, which is your weight, and then your 2 mg is equal to your tension. This is your tension, right? Tension here. Okay, so your centripetal force is equal to 3 mg. All right. Next, now your rod is, the ball is at the bottom. All right. So at the bottom here, right, you need to draw a free body diagram. Okay. So let's just quickly do it this way. You have your rod here. Okay, and then you have your ball here. All right. So quickly drawing the forces. You have your tension, and then you have your weight. All right. Your net centripetal force, your acceleration, right, is towards the center like this. Okay, so your centripetal acceleration is this way. Okay, so that means your net force must also be upwards. That means now this is Fc equals to T minus W. Okay, Fc should be the same as the previous part, so that's 3 mg. Okay, so we have 3 mg here. Mg equals to tension minus away your weight of mg. So T is just equals to 4 mg. Alright. Okay, moving on. Okay, next you're asked to work out the angular speed of the ball when you're given the distance 0.72 meters. Alright, so you know the resultant force. This is just your centripetal force. Okay, so remember, since the speed is constant, right, the centripetal force is also constant as well. So this one should be 3 mg. Alright, so then you just sub in the value. Okay, I think this one was okay. Some of you just made a careless mistake because you can work out. Instead of you did not understand what angular speed is. Okay, you did not see the meaning of this word here. Alright, so you go and use Fc equals to mv square over r, and you work out v. But v is actually your linear speed. Right, this is linear speed. Okay, so just be careful. Okay, so once you work out your angular speed of 6.39 radians per second, you can just use v equals to r omega. Okay, work out your linear speed now. This is your v. Okay, next work out your acceleration. You can either use r omega square or v square r. Okay, and you should get 29.4 meters per second square. Okay, we apply ECF for this two parts here, part 2 and part 3. Okay, last. Okay, linear speed of the ball remains constant throughout. Explain how a resultant force acts on the ball to cause acceleration, but there's no change in the kinetic energy of the ball. Okay, so this one here, right, we are not asking you to say, oh, because speed stays constant. Okay, so basically here a lot of you made the mistake of saying, oh, because your question says that speed is constant, therefore kinetic energy has no change. That's obvious, but you're not supposed to do that because you're supposed to use the resultant force. The key is this resultant force here. Okay, there's a resultant force causing acceleration. How come there's no change in your speed? Okay, so you can go by it from two approach. One, just using the vector. So in this case, you just need to say that, oh, because your resultant force is perpendicular to the vertical, to the displacement. Alright, so basically you are saying that, oh, because my resultant force is this way, Fc, and then my displacement is actually in this direction, delta S. Okay, so because Fc is perpendicular to delta S, that means the work done by Fc is equal to 0. Alright, so that's it lah. Okay, if you want to, right, or you can just basically say that because your force is perpendicular to your displacement, right, you are just changing the direction and not changing the speed. So that's fine as well. Okay, so yeah, that's it. Same thing. If you need help over the next 2 weeks, please ask. There's not much time left before your MIA exams are, and a lot of you need to buck up a lot for your MIA exams. Okay, that's all. Thank you. Bye bye.